So what I'm going to talk with you guys about today is value engineered AI, making it matter. And informally, what I've always said to my teams throughout my career is the question they always hated hearing from me. I know I annoyed all of my data scientists, and that I would respond with, "So what?" We got to answer the "so what," and this isn't necessarily specific to AI and data science. It's kind of a technology question. So any corner of technology, you can really invest deep. You have to make sure that you're applying the technology to the right problem. So we're going to talk through a few things. I know you guys have heard a couple different definitions of AI. I'll provide my perspective. It's good to hear different angles on what this stuff is, just because it's so hyped today. And knowing how, when, and where to use this information is absolutely critical. So I appreciate the intro. I had this slide in there. I didn't realize that was going to happen, but I'll just talk a little bit about my perspective and what I bring to this event here today. You guys are hearing from some amazing and impressive professionals here that are doing some wonderful things. What I provide from the consulting angle is the perspective that cuts across various industries. So right now I have about 300 management consultants in data strategy and AI across the country, and also have international engagements. I've talked to about 300 clients already this year, both personally in a strategic consulting role and through the engagements that my team is currently attached to. And then about 80 active engagements right now in AI and ML. So the common questions that I get asked all the time is, where do we start? And how do we make sure that we're investing the right money? How do we know that we're getting that ROI? How do we track against it? So what I'm going to be talking about a little bit here today are the frameworks, some frameworks you can use to think about. So feel free to take pictures and kind of digest, and I'm more than happy to have conversations with you guys afterwards and go a little bit deeper. But I'm also going to talk about some more commonly, maybe they're commonly understood, maybe they're not, but some, I would say, accessible use cases that we may have learned about, both in pop culture and in industries we are probably either in or interact with, so that way I can kind of drive it home. I'll start with those use cases, and then we'll talk a little bit about the frameworks. But that's my goal here today. And like I said, I love talking about this stuff, so if any of you want to kind of come up and go deeper on the material you see here, I'm more than happy. So let's see. Let's start first with one of my favorite memes. AI is super hyped, and people are scared of it a little bit. People are excited about it, and everything in between. And I agree with that. We hear things all the time about AI is going to replace jobs. It absolutely is. There's a study out there, and forgive me for forgetting exactly the name of it, but there's this recent study, economic study, about how many jobs AI is going to replace. It's going to replace 85 million jobs in the next 5 to 10 years. But it's going to create 97. It's going to create, not 97 million. So yeah, we're not that far in the hole. 97 million. So there's going to be a net add. And there's a lot of hype in AI, as we all know. We're all here talking about it here today in the context of supply chain. And I graduated into the dot-com bust. A lot of what this feels like is the dot-com boom. A lot of people are rushing towards AI solutions, maybe a little bit cautiously, because the dot-com bust wasn't that long ago, and a lot of people are still in charge running major technology organizations. But the point is, there's a lot of hype. There's a lot of fear. There's a lot of trepidation. There's a lot of questions around this. Everybody said, when the dot-com, when that bust happened, everybody said, oh, the internet's a fad. Web e-commerce is a fad, but I mean, how many people here, show of hands, are buying stuff on Amazon every single week, right? Yeah. There was a great podcast I listened to. My wife and I, when we were driving our kids to vacation this summer, it was an economist that invested in technology during the dot-com bust. He said he finally had enough. He was a professor and a VC, and he jumped in himself on an online pet store. We all know that that's a viable economic model right now. He went bankrupt in like 3 weeks. And the reason being, they rushed into it. They didn't ask the right questions. They didn't ask the so what. In summary form, they had all of their contracts lined up for purchasing goods in bulk, dog food. They had a perfectly hardened web presence with all the PCI compliance and e-commerce transaction all in place. Everything was great. And then they went live. Nobody asked how much it cost to ship a bag of dog food. So they burned through cash in a matter of weeks and ceased to exist. So those are the types of questions that you always have to ask as it pertains to technology, applications, and investments in it. Even if a business model is sound, spending more time up front and digging in to what that so what is and truly pursuing value engineered AI is absolutely critical. So let's talk about first pop culture example. Everybody knows this movie, Moneyball. We mentioned that I teach here. This is a big part of what I teach in a machine learning class. And I don't know if anybody here makes that connection right away. Moneyball, machine learning AI. This is very much a movie about data science, 100%, no doubt about it. One of the previous speakers was talking about narrow versus broad AI. This, in my opinion, would be an example of narrow AI, where they were focusing on a specific problem. And then bringing it into context for this event, supply chain, I'm providing a lot of examples here to you guys in the context of service supply chain. You're dealing primarily in physical goods shipment. This is furthermore classified as a data science movie about the service supply chain. And the service is the delivery of talent, in this case, professional baseball players. There's a wonderful line in this movie where Billy Beane, Brad Pitt, the manager, is talking to all of his scouts and to kick off the season, to recruit, and everybody's upset that they lost Jason Giambi. And he continued to push the point that we're not going to replace Giambi, but we're going to replace him in the aggregate. It's a perfect data science statement. You're going to take this, let's call it $15 million a year superstar, and then you're going to replace all the talents, tools, and the so whats, the value components that he brought to the table and the team for a lot less money with the same level of effectiveness, if not more. That's the problem that they were solving. They had like a $40 million budget. I think the Yankees had a $250 million budget going into that year. So they were they're fighting an unwinnable war from an economic perspective. So they focused, they dug in deep, and the question that they answered was, around the so what of what does it take? What are we doing? What are we? We're a professional baseball team. Okay, what is our mission? To win games, to win the World Series. As Billy Beane put it, win the last game of the season, which is the World Series. How do you do that? They kept asking these questions and digging and digging and digging, and what they found out was the only thing that mattered at that point in time, in that version of the game, was if you got on base. That was their KPI. That was their metric. They built everything, every analytic, with every data point they possibly get their hands on to figure out who got on base. They didn't care. And the movie is also a wonderful business case. If you watch it and read the book's better, but when you watch the movie, I'm sure all of us have been, I know I have, we've all been in the conversation where people are pushing back on this new idea. It's a pretty colorful exchange between him and his lead scout around how much this is not going to work versus, or not versus anything, but just that it wasn't going to work. So they pushed forward because they were in such a desperate state in the Oakland A's with their budget that they had to try something. So, and we all know it does work. It did work. And the beautiful part of the story is that data science and machine learning, AI, whatever we want to label it in this particular case, completely transformed an entire industry, Major League Baseball. At the end of the movie, by the end of the story, the Boston Red Sox offered Billy Beane the highest salary in the history of baseball as a manager because they recognized, oh my gosh, the game completely changed this season, completely. And there's a great line at the end too where he says, if anybody is not following this analytic method the way you have pioneered it in Oakland, they are going to be dead. They're going to be dinosaurs. And that lesson applies to a lot of us in this room. We know all this fear around AI. We know this story, this template of this story is unfolding in all of our industries at different paces and in different form factors. So there's this temptation to rush into it and spend a lot of money. AI is expensive. It is not cheap, at least in its current state. It will get cheaper. It will get commoditized. At least corners of it will. But there's always going to be a bespoke build. And that means you have to stay focused on the value. Start with the business problem first, and then ask yourself, is this a problem that fits the AI solution? I have this conversation with executives all over the country every single week in every single industry. And with companies that you would be surprised, you feel and you think they have this all locked down. On the topic of Moneyball and the fact that this whole story took place in the early 2000s, so almost a quarter of a century ago. Just last month, I was in Philadelphia and hosted a roundtable with the Philadelphia Eagles, the 76ers, the Flyers, the Union, and did I miss anybody? Eagles? Did I say Eagles? It's a headache. Who? Phillies? I didn't say Phillies. All of them, whatever. There's 5 of them up there. We've got 3. And every one of the individuals that were basically Billy and Paul up here, they were working on spreadsheets. Like, you think of the Eagles, you think of the Phillies, you're like, oh my gosh, this huge brand, they've got it all figured out. And plus, sports analytics has been around for almost a quarter of a century now. They don't. I shouldn't say that out loud, but they're working through a lot of the same data challenges that all of you are. And they are dealing with the service supply chain issue of their talent, making sure that they have a fresh pipeline of talent that are coming into their franchises to put a good product on the field so they remain profitable and viable. It is a service supply chain problem. It's wonderful, it's fun, but my message here is that we're all going down this journey at different paths and different paces. So don't rush in. Stay focused on that business value and make sure you're digging in deep and asking the so what. You're going to annoy your business partners or even your own technical teams. But the more you dig in, the more you're going to avoid throwing really good money after bad ideas. So, industry that I worked in for the longest period of time, healthcare. I was in healthcare for 17 years. When I left, I was head of enterprise data science for Evernorth, which is a subsidiary of Cigna. And we worked on a number of different problems in healthcare. Again, more of a service supply chain. We weren't manufacturing drugs. We weren't physically creating devices, but we were providing a service to healthcare in administering benefits and insurance and in some cases, a physical pharmacy to a lot of our patients. But we covered 110 million Americans. We had over 30 petabytes of data. I have a former colleague here in the audience here. 30 petabytes of data, is that right, Mark? Yeah, he was 50, we'll say 50. It was a lot. We were dealing with a tremendous amount of information. So the frameworks that we're talking about and the stories we're talking about right now were very relevant because we would sit down in a room and say, okay, where do we start? What's the most pressing problem? The mission of the organization I was a part of was to go solve the biggest problems in healthcare. And you look at your Linux screen with the blinking cursor staring at you, and it's like that college experience of like, oh my gosh, I got to write a paper. Where do we start? But I'm looking at 50 petabytes of data. So it wasn't quite that chaotic, but we had some focus areas, and one of the things that we worked on, and I continue to work on in consulting, is prior authorization. Everybody in this room, if anybody has had any type of a procedure or a drug or interacted with healthcare, you have fallen victim to the prior authorization problem. It basically, if you've gone to paint a picture of how this works, you go to Walgreens or CVS, get a drug filled, and they say, hey, I got to call your doctor. And then they play communication ping pong for a few hours or days, and then you finally get your drug approved exactly as it was prescribed. That's prior authorization. Massive amount of waste. Healthcare knows that it's a problem. They're all trying to solve it. We're digging in really, really deep on the prior authorization problem with a client that I can't release the name, but they are a information service provider that's kind of behind the scenes of all the biggest healthcare players in this country and in a very large health system in the northern part of the country, and trying to connect them to pilot how we can optimize the prior authorization problem with artificial intelligence. What we're starting with, in this message here, is really about crawl, walk, run to start to uncover that so what. They know that they have doctor's notes and EMRs and EHRs, electronic medical records, electronic health records, so companies like Epic provide those and hospital systems use them. Those scripts and procedure diagnoses and requests to the healthcare providers go through this switch, this client, we'll just call it client A, and they see all this information, and they help administer the prior authorization problem. It's not the only thing that they do, but it is one of the things they do. So what we're doing is we're digging into the doctor's notes, starting with really basic text mining and text classification on the topics that the doctor is saying. That's where the richest data set is. And then we're going to continually move them down the maturity curve with the analytics that we're developing to start creating interactive and deductive insights around how well a particular physician is adhering to all of the guidelines needed to approve this process or this drug quickly, and effectively creating a gold card for physicians. Meaning, if your physician's really, really good at the administrative side of diagnosing you and prescribing you a drug or a procedure, he or she will be shot through the system a lot faster, and it will uncover massive, massive economic efficiencies and service efficiencies in the healthcare service supply chain. So it's really, it's a problem that we probably don't think about overtly, but we all deal with indirectly as patients. So very, very exciting with really, really large dollar amounts tied to it. The so what here, answering the so what, is really focusing on the biggest pain point for both patients and the healthcare system and trying to find the efficiency. In this case, we're going to start with a lot of text mining, and we will eventually get to large language models and RAG architecture in these solutions, but we're starting small to prove this out and then move up the maturity curve, which we'll talk about a little bit later. And then, of course, this is something we deal with every single day. These are companies that are driven and built purely on data. All of them are gathering data on us all day long, every day. Right now, Apple and a little bit of Google are listening to this presentation. And then they're going to absorb it into their models. And we've all authorized them to do so with the free services. And you know, it's a love it or hate it, it's happening. I still laugh and chuckle when the articles came out. I think it was like 10 years ago, people got all up in arms that Google was reading their email. I'm like, of course they're reading your email. They gave it to you for free. That's how you pay for it. You've turned over your information. Same thing with Facebook, same thing with Instagram. So they are data-driven companies. Their so whats are in all different kinds of angles, but effectively the big so what is how they can create hyper-focused marketing insights to sell you things. Not necessarily them, but sell your data to others who then can sell stuff to you. So a purely data-driven business model. And there's a lot you can learn by studying these companies, because there's components of how they've operationalized data as a true asset that would translate very well into all of your business models. So although you may not, or some of you are, some of you may not be, technology first, technology only, like these firms up here, but there are components to your data assets that then become incredibly valuable to you and your business model and the industry you operate in. One of the ways I talk about your data assets, is truly a new business asset for you, is that it's your unique fingerprint on the economy. Just because company A and company B do the same thing, make money in the same way, and operate in the same industry, does not mean their data assets look the same. How you track, manage, govern, and operationalize those data assets, especially as it pertains to AI, matters, and it's going to matter even more, and that's going to accelerate over the next few years. It kind of clicks down into a whole other framework that I'm not going to talk about here today, but how do you operationalize your explicit data, your transactional data to run your business, and then how do you capture your latent data that you haven't quite already captured, but with hardware and software that continues to emerge, you can start to capture it. But your data is your asset. And if you can operationalize that and borrow something from what other companies have done to answer that so what within the context of your industry, then you've started to operationalize this asset, and the ROIs are there. The ROIs may not be directly attached to the analytics solution, but the business problem that you're driving to solve. So, what does that mean? The hardest part of AI and ML, the technology's hard, the math is hard, that's true. But The hardest part, what I would consider the harder part, is answering the right questions, which is what we're talking about here. In baseball, the first example, they had the 5 tools, at least that the scouts used for over 100 years. For 100 years, people thought that that's how you identify talent. That was fundamentally false. It only mattered if you got on base. That was it. And there was data that could lead you directly to it in a very simplistic way. So having the persistence and the courage to kind of keep digging in to find what those questions are that you need to answer, and then ask yourself, does AI apply to this? That's critical. That's how you'll be successful. Let's talk a little bit about the framework. So let's say you're starting out, your CEO or your board has asked you, okay, we need to do something in AI. I've been asked that hundreds of times this year. We need to do something in AI, help us. And it really starts with problem classification. And the way that I've kind of developed a framework to approach this, it's not rocket science, there's nothing terribly complicated up here on the screen, but to break it down into 3 classifications. Like, what is it that you're trying to achieve? You're either trying to do something for the enterprise, you're trying to enhance or create a product, or you're trying to create a new revenue stream or enter a new market. So enterprise, product, and market. Enterprise is where you're taking AI and you're pointing it back into your own business model. You're fixing things like revenue cycle management, quit rank, trying to make sure that your best employees don't leave you, finance and pricing optimization, things that all help a lot. You're not going to read a ton of articles about it on LinkedIn or Fast Company or whatever the publication may be, but they make a lot of money for you. There's a ton of money to be made in the enterprise category, and that's generally where you start. Let's start, I'm not saying always, but generally, you would want to start asking those questions about what could be fixed inside your 4 walls. And that's incredibly valuable because 1, you're going to learn a lot as an organization as you move through those problems. 2, it's safe because it's just you. I mean, not perfectly safe, but you can control the problem set for the most part. And then you build technical precedent. You will build technical precedent on how you organize the data, govern the data, how you move through the entire analytic maturity curve, and then operationalize something, and then learn about how that ROI is materializing inside your business model. That is incredibly valuable learning for you as a firm. That can then allow you to step up the scale into your products. Everybody here either sells a physical good or a service. That's what I mean by a product. One of those 2 things you're making money on, and you can inject a physical good or a service with artificial intelligence to make it more valuable, to make it more competitive, to allow you to produce more of it for less money. There's a whole host of options there. This one's a little bit more risky because now you're starting to inject a very advanced technology into how you make money directly with your clients, and that's okay. As long as you learn the right lessons and you have the right technical precedent in place, you know where the edges are for your particular fingerprint on the economy, your data asset. So you'll be able to move through and start small and crawl, walk, run. And then the third bucket, which is very, very exciting, and it's a lot of fun, but probably more rare, is when you start to uncover opportunities to enter new markets or create new revenue streams, and to leverage your data as a direct, pure, only product. All the wonderful things that the other folks have talked about up here and those in the afternoon that have built in their respective industries are all in some way, shape, or form monetizable to some other industry that's adjacent, or a potential to create and expand their fundamental business model. So there's a lot of precedent here. In my career, I've had experience in deploying and seeing the financial and economic success in all 3 of these categories. So by starting first with this classification, you start to clarify the strategy. You start to tighten the bullseye on the problem set that you're trying to solve. That way you're not trying to solve everything everywhere, because especially in AI, ideas are cheap and execution is incredibly expensive. So people are going to have all kinds of ideas about what you could predict and what you could classify, and we can chat GPT this, and I get it. You got to stay focused. That's the point. So what is AI? And there's a lot of different definitions. There's a couple other slides I have here too, but there's a lot of functionality. I'm not an artist. engineer, so I have to stick with edge shapes. But basically, I started with like a glacier and iceberg. I'll step out of the way if you guys want to take pictures. But basically, somebody's asking about an AI initiative or an AI capability. That's the top of the iceberg. That's what everybody's talking about. That's what everybody sees. That's what everybody is getting excited about and fearful of. But all of these things, this isn't fully comprehensive, but gives you a good idea of some of the big building blocks that you need to have in place in order to make this work. There's some wonderful and impressive stuff that I heard just in the previous talk from Bayer on the things that they've built in the ecosystem, and both internally built and third-party partnerships. That's wonderful. There's a build versus buy question here, like there always is in technology. It's just a question of how much you want to control, how much is your IP and competitive, and how much you want to outsource. But all that being said, these are the pieces that you need. You need to make sure that you have a data governance, process in place. You don't have to boil the ocean and do this to every corner of your data assets at your firm, but at least attached to the data domain in the problem set that you are pursuing. So everybody thinks it's magic, right? Everybody thinks, just hire a bunch of data scientists, sprinkle some data on them, and out pops a new business model. Well, there's a lot of different layers to data science and advanced analytics, AI, whatever we want to call it right now. This is just a little different angle to the pyramid there, and more of a linear fashion. Don't take this slide as, these are the steps explicitly. You have to take all these steps in every single project that you do, but these are the components, generally speaking. Think of it as more like a river that's flowing in that direction than a hardened process flow. But these are the components of what you need to do. And of course, depending on what industry you're in, you want to make sure you keep a sharp eye on legal. Everybody should be thinking about ethical and transparency issues. Historical bias, security, there's a lot of questions about security. That's going to be a growing area. And then another interesting area, I need to probably put another bar down there, is energy efficiency. Have you guys heard about that? Like, show of hands, energy, very resource greedy. Think about it. Any of you who have kids who've ever built a gaming PC, they have liquid-cooled gaming PCs. That's just for a game, for one kid playing a game. And now imagine throwing that kind of architecture against 50 petabytes of data. You are truly, literally boiling the ocean. So that's going to be another emerging topic in the AI space is how do you actually physically power the apparatus, the hardware that's driving these insights. So a lot of different considerations as you enter into these projects. And there's a lot of, I preferred the previous definition on AI. This is more conceptual and much, much higher level on what AI is. But I use this slide to kind of simplify it with my leadership, in that everybody is conflating Gen AI with AI. And again, not a perfect academic slide, but the point here is generative AI, what we're all learning about with ChatGPT and large language models is a component, it's a sub-bullet of AI. Artificial intelligence is this huge ocean of capabilities, and attaching those capabilities to the right problem, like we're talking about here today, is absolutely paramount. I love the framing of narrow versus wide, or narrow versus general AI. Narrow AI is incredibly valuable. Just like the Moneyball example, that was narrow AI. They were focused on a single question, and that question got them 21 wins in a row, broke all kinds of records, and changed the entire sport forever. Broad AI is what we're starting to experience with things like ChatGPT. It starts to scratch the surface of artificial general intelligence, in which we all think of when we think of AI, like a robot that interacts with you like a person, or a self-driving car that can literally drive itself across the country. But the idea here is that it's all layered, and there's different capabilities and components across all of those layers. And not everything needs to be AI. Not everything has to be predictive or classified or supervised, unsupervised. There's some very fundamental statistics that you can apply to your data assets that yield tremendous amounts of value. So we asked the so what. This is probably just another good process slide. I won't spend a whole lot of time here, but it's very high level, not quite fully academically ML ops, but generally gives you another flow. Think of this as like a river slide again. Like, you generally move left to right. this tends to be more cyclical, but you spend, let's see, is there a laser here? Yeah. So you spend the most time here on classifying your pipeline and prioritizing it based on your business strategy. All this stuff becomes plug and crank. You want to make sure that you're spending a lot of time here. This is what I refer to in class as like the fuzzy front end. You want to create some sort of a process in which you're catching all of these wonderful ideas. Yes, they are cheap. Yes, they are plentiful. One of our clients we're helping them sift through 9,000 use cases that came to them in a matter of 60 days. I think we've landed on 8 so far. So optimizing this is a process in and of itself. But then you harden and classify those business models or those business cases and prioritize them. And then you operationalize the powerhouse and your chief data officer and AI group and deploy and monitor and make sure that that the business case persists, that value is still there, that it's still relevant, and that the model is still delivering the way it should. I'll give you an example. If we all worked for Vanguard or pick your financial mutual fund company, and we built a model that targeted certain companies in a certain sector and industry, and we built a wonderful model on picking stocks that go into that mutual fund, that model is only going to have like a shelf life of maybe 6 months at the most, because the economy changes. Companies go out of business. New companies form. That industry may be affected by regulation or socioeconomic or global issues. So the fact that you have to constantly monitor what you've built is incredibly critical, and that's a whole other process, and that's what I'm really referring to over here. Is this business model, is this model still relevant to our target of profitability? Is this still relevant from a quantitative standpoint? Did we miss something? Do we need to go back and correct? And then that should go right back in the pipeline, and that you're reevaluating, reprioritizing, and getting it back in the pipe. So this cycle should never, ever end. Just like if anybody like me, like a consultant stands up in front of you and says, I'm going to fix your data ecosystem and it's going to be pristine and perfect forever, they're lying to you. 100%. I never say that. And I think all of you guys know that. It's a living, breathing asset that's going to constantly change. The name of the game here is making sure that you stay focused on the right corners of it and extract that value. So I talked a little bit about the analytic maturity curve. There's value to be had in all of these analytic layers. So what has happened? This is statistics 101. This is what we all learned about, averages, means, all that fun stuff, basic. And then, why did it happen? Descriptive, and then getting all the way up to deductive or cognitive, in which you're simulating or starting to open the aperture on artificial general intelligence and interactive analytics. All of this stuff has power and value. Generally speaking, sorry for the, that's all right. Generally speaking, you start to really push the envelope of business value and start pushing into the product and market space on the upper end, generally, but that doesn't always mean that's the case. And in a project, in any AI project, you're almost always starting here. You have to know what happened in order to drive towards the problem and the question you're trying to answer. So that's the analytic maturity curve is absolutely critical. And then finally, who does this? This is, again, very high level, meant to be more kind of a catch-all concept. We all know and talk about data scientists all the time. Data engineers, and these three are getting incredibly important. Data scientists are still critically important, but if you're building a broad-based, let's say if you're building a chief data officer organization, and say it's made up of 100 people, I'd say 20 of them will be data scientists, 80 of them will be in here. Without these, they won't have a lot to do. Or you're asking the data scientists to do all of these things at the same time. So it's really, really critical. And why is that? Data engineers and architects need to make sure that the data assets are structured such that they're usable, that they're accessible, that they're scalable, that if your data scientist puts together a basic binary classification and logistic regression, it doesn't melt servers off the rack. That's why these guys are here. This person is here to make sure that if I'm looking at a pharmacy claim, that is a pharmacy claim, that is the patient's name, that is their social security number, that is the drug. Governance is absolutely critical. Without that process, the quality, the provisioning, and security, then these guys don't know what to structure, and this guy can't do his job. So it's all equally critical, but when you're thinking about volume, if you're building the algorithms, it's generally a smaller team, and this is a larger army standing behind him or her. And that's generally speaking how it's worked and how we're starting to observe success through all of our client engagements.